The world around us is dominated by change and motion, and everything in mathematics is created out of necessity to understand our world better. Calculus is a branch of mathematics that studies motion and change, and because of its fundamental nature, we see it everywhere in all disciplines, including other branches of mathematics. The main object that we work with in calculus are functions. Informally, we can think of functions as a rule which tells how different things are related to one another. And learning how different things relate to one another is one of the foundational tenets in learning. However, before we delve deeper into calculus and functions, let's take a step back and discuss what a real line is. So most quantities that we study are measured using the real number system. The real number system is composed of several numbers. Natural numbers, which were initially used for counting, that starts from 1, goes all the way up till infinity. And when 0 was invented, we stuck 0 to natural numbers, and then whole numbers were born. And when trade became prevalent, we needed a mechanism to represent the notion of credit. So negative numbers were invented. And the set which contains the negative integers 0 and the positive integers became the set of integers. Now, you can also divide different integers to one another, and all the numbers which were created by dividing two integers together became rational numbers, as long as the denominator is not 0, because division by 0 is not allowed. So technically, every integer is also a rational number because you can express every integer as that integer divided by 1. There were also irrational numbers, which were numbers that were not rational, meaning they could not be expressed as a ratio of two integers. Examples include root 2 and pi. Thus, you can say that a real number system consists of both rational and irrational numbers. Now, graphically, we can represent the entire set of real numbers using a single horizontal line. So how we do that is, we first draw this horizontal line with two arrows in the end. We pick an arbitrary point on that line, and that point becomes the 0 or the origin. We then pick another arbitrary point to the right of 0 and call it 1. Now the distance between the 0 point and the 1 point is the unit distance. So now we have a reference scale, and using this scale, we can place any point from the real number system on the line. Now when we lay out these numbers graphically on the real number line, we also see an inherent order to them. That is, as you move from left to right, there's a linear incrementing of the numbers. So if we pick any two arbitrary numbers, let's say A and B, from this number line, if A was to the left of B, then it means that A is actually smaller than B, and we represent that using the less than symbol. Likewise, if A were to the right of B, then it means that A is actually larger than B. And we can represent that as A greater than B. We can measure the distance of any number from the origin where it all began, which is 0. And since distance is always a positive quantity, this distance is actually called the absolute value of a number. It's denoted by two vertical lines with the number stuck in between, and it's always a positive value. The third thing that you can observe on a real number line is you can cut it into smaller pieces. And these segments, when you cut the real number line segment into smaller segments, these segments are called an interval. And let's pick two random numbers, A and B, as the endpoints. of this segment, then the interval a comma b includes every single number between a and b. We also get to choose if we want to include the endpoints in our interval. If we choose to include it, then our interval is called a closed interval. If we choose to exclude them, then it becomes an open interval. That's all we have in this session.